Hello, good day. My name is Sudama. I'm from the Methanex Trinidad site, and I'm here to explain to you the PSA, an overview of the PSA unit, which they are trying to incorporate on the Chile 4 plant as of now. PSA definition: the PSA, or pressure swing absorption unit, is a process in which molecules of a gas attach themselves to the surface of a solid when the two separate components interact. PSA is an adiabatic process and is based on physical absorption phenomena. The process is used for purification of gases by removing impurities through absorbance in fixed beds contained in pressure vessels under high pressure. The PSA process provides a low-cost method of increasing availability of high-purity hydrogen and of better utilizing this waste stream. The PSA package consists of a skid. The major parts are valve and piping skid, the control system containing the cycle controls, 6 absorbers, 1 cartridge filter, 1 off-gas drum, and 1 feed filter. An overview of the PSA: the absorbent molecular sieves are a complex mixture of elements and compounds such as aluminum, silicon, oxygen, and sodium. These elements are combined to form a stable ceramic mixture. Entry into its rigid hollow structure, where molecules such as carbon monoxide, carbon dioxide, methane, argon, and N2 can be stored through the pores on the structure. The cells of a molecular sieve link together naturally into a structure known as a crystal. This crystal contains a network of cavities formed by the walls of the molecular sieve cells. Fluid molecules larger than pores cannot enter. Absorption of gaseous components on the absorbent molecular sieves are determined by several factors, of which volatility and polarity are the most important. As process conditions approach the dew point of a component, a less volatile component is absorbed from the gas phase. Electrostatic forces further aid absorption. These molecules are attracted by the absorptive forces of the positively charged cations contained in the crystal lattice of the absorbent. Inert gases in the synthesis loop take no part in the reaction, nor are they catalyst poisons. But they must be removed from the loop, otherwise their concentration would build up, dilute the reactants, and quickly affect the process by lowering the partial pressure of the reactant gases. The purge gas contains not only the inerts or impurities, but also hydrogen. These impurities are absorbed after passage through the pressure swing absorption unit. Apart from pure hydrogen product, the PSA system produces a low-pressure gas stream, the tail gas, which is used as fuel. The PSA skid, as explained before, contains of valving, hydrogen filter, the feed filter, 6 absorbers, and 1 tail gas drum. The operation of the PSA: during operation, at least 1 absorber is on stream at high pressure and separating the impurities from feed stream, while the other absorbers are regenerated. The control programs ensures the process sequencing and the changeover of the on-stream absorber in such a way that the impurities never escape from the on-stream absorber to the product. Therefore, the sequencing must ensure that another absorber always regenerated sufficiently and pressurized during regeneration period in order to replace the on-stream absorber before its absorption capacity is exhausted. The design data of the PSA. The PSA unit has been designed to produce 16,694 normal meter cube of hydrogen out of 30,723 normal meter cube of methanol recycled gas from the synthesis loop at a pressure of 34.8 bar gauge with a recovery rate of 82%. The design covers the PSA unit operation with 6 absorbers. In case of a field instrument failure, the PSA control program automatically switches the malfunction absorber out of service, ensuring continuous plant operation with a reduced number of operational absorbers. The minimum number of absorbers in operation is 4. The PSA unit is designed for continuous operation at all loads between 40% and 115% of normal product flow rate at specified product purity. The PSA unit can be operated with a feed gas pressure range from 26 bars to 35.2 bars. The PSV is provided on the outlet of each absorber with a set point of 38.5 bars. the maximum feed gas capacity decreases with decreasing feed gas pressure. The PSA is designed with a shutdown logic control loop. The objective of the PSA unit trip logic is to protect the PSA from abnormal process conditions. Process conditions extremely different to design conditions might result in an irreversible reduced process capacity of the PSA unit. Based on expected impact of abnormal process conditions on process operations, the trip logic must protect the PSA unit from conditions which might have a negative impact on process performance. The PSA trip logic can be activated also by external request signals or operator access at PSA PLC human-in-machine interface. The PSA shutdown alarm will result in the following actions: setting of shutdown alarm setpoint, setting of PSA sequence controller to stop, and terminating of PSA sequencing and closing of all PSA valves. PSA sequence. One PSA cycle is built up of two basic phases, absorption and regeneration. The regeneration phase itself is a chain of sub-phases consisting of high to low pressure transition, expansion or depressurization, provide purge and dump. Number 2, purging at low pressure. Number 3, low to high pressure transition back to absorption pressurization. PSA cycles, as described before, is absorption, whereby the feed gas goes in the bottom of the PSA absorber and out comes the H2 product. Co-current depressurization, where one absorber is out of the absorption process and is using its purge to repressurize another absorber. Co-current depressurization, purge at low pressure and repressurization of the absorber. PSA characteristics: feed gas capacity versus absorption and desorption temperature, and factors that can affect it. Feed gas capacity of absorbent material decreases with higher feed gas temperature, but the purging effect is better at higher temperature. Also, at given absorption and desorption pressures, this effect results in a lower differential loading. Absorption at temperatures below 10 degrees should be avoided because of the negative impact of low temperatures on purging effect. With increasing temperature, the gradient of this absorption isotone decreases. The absorber capacity is influenced mainly by H2 content or by molecular weight of the feed gas. The possibility of non-reversible overload of absorbent materials is with respect to decreased purgeability of that component in upper layers. In addition, any liquid in the feed gas must be avoided because liquid would damage the absorbent material. The optimum temperature for the PSA process is in a range of 15 degrees to 40 degrees. Higher temperatures are permissible, but increased temperature reduces the absorbent capacity. PSA product uses. Hydrogen required for the methanol process is obtained by generating it using a combined reforming process. Extra hydrogen is therefore obtained by recovering it from a hydrogen-rich process stream or purge gas using the pressure swing absorption process, which would otherwise be only used as a source of fuel. The pressure swing absorption unit operates with a alternating pressure increases and decreases. Unwanted components of the gas are absorbed, leaving a product gas with the constituent wanted in the required concentration. Although the process is a batch operation, continuous product and off-gas flows are achieved by using 6 absorbers operated in a specific cycle. Advantages of the pressure swing absorbers. Some of the advantages of the pressure swing absorbers are a higher hydrogen partial pressure in the downstream reaction section. The amount of byproducts are reduced in the loop. Utilizing of the reactor loop purge gas produces hydrogen at essentially feed gas pressure to the absorbers. No feed pretreatment is required. Minimum manpower requirements due to automatic operation. Process safety. The main concern in keeping the PSA unit running properly is to protect the absorbent from any damage. The load of the absorbent initially supplied should be good for the life of the unit, provided correct care and maintenance are given during operation of the unit. The two main situations to avoid in order to protect these absorbents are rapid pressure change in the vessels and heavy impurity loading. At rapid pressure changes in vessels, the process is a pressure swing operation with vessels continually cycling between absorption pressure and waste pressure. The normal pressure swing for 6-bed operation will not damage the absorbent. However, improper manipulations of the valves can cause bed lifting or crushing. This pulverizes the absorbent and the resultant dust will seep through the retaining screen in the vessels. Pressure drop through the vessel will increase and seed damage in the process valves if possible. This, along with the instrument lines fouling with dust, makes for a very poorly functional unit. And also heavy impurity loading. Heavy impurity loading occurs when the amount of impurities entering the absorbent with the feed each cycle exceeds the absorbent's capacity. First indication of this will be a decrease in product purity, followed by the inability of the unit to control pressure changes functions. Okay, what you are seeing here in this video is the valve piping skid on the Atlas plant in Trinidad and Tobago. Okay. In closing off, the PSA will most likely be used in the Chile 4 plant for the production of hydrogen into their ATR reformer.